Hello everyone. In this chapter, we're going to be talking about rigid body kinematics. So rigid body kinematics is a combination of rigid body translation, which is just an extension of what we talked about with particle kinematics. So we're just following the center of mass of the body for the most part. But also with rigid body motion, we've got rotation. So if we've got fixed axis rotation, this is where we have rotation without translation. We're going to have two methods to look at that. We've got scalar methods, which we can use our right-hand rule, as well as angular velocities, angular accelerations, and distances. Or we can use cross products in our vector methods. So either of these should give us the same results. It's just we've got kind of two options for looking at this. All of these are going to be built on working with the system in the polar coordinate system, where we've got the r and theta directions, and the r is going to be our distances. The theta will relate to the angular velocities and angular accelerations we have. So if we pull rotation and translation together, we have what's known as general planar motion. So with general planar motion, we're going to have four different options for how we analyze these systems, how we relate the position, velocity, and acceleration of individual points to the larger motions of the body. So first one is going to be absolute motion analysis. This is kind of the brute force method, where we are going to come up with a series of equations that are going to relate the positions, and we take the derivatives to find velocities, the derivatives again to find accelerations. Next up, we've got relative motion analysis. So with relative motion analysis, we're going to break the motion of the complex motion down into simple pieces, and then we're going to use pre-derived versions of those equations we had in absolute motion analysis to create, kind of stitch together the motion of more complex pieces. Next up, we've got what's known as instant centers. So instant centers is a method where we basically are going to try to turn a general planar motion, which is translation and rotation, into a fixed axis rotation problem. So there's always, at an instant in time, there is always kind of one point that can be the center of rotation. So if we find that point, we can treat it like fixed axis rotation. And then our last method is what's known as rotating frame analysis. So this is kind of an extension of our relative motion analysis, a little more complicated piece of that puzzle, but another version of relative motion analysis essentially there. All right, so that's what we're going to talk about in this chapter, and we'll see you later.